This question is worth 12 marks. A geometric sequence has first term 4 and p as its common ratio. An arithmetic sequence has first term 4 and 5p as its common difference. And then there are three questions that follow. Additionally, for some values of p among those found in C, the sum to infinity of the terms of the geometric sequence exists, and there are two questions to be answered. Given the information above, we can now answer the questions A and B. Question A, write down in terms of P the first four terms of the geometric sequence. So our answer B will be 4, 4p, 4p squared, 4p cubed. That is multiplying each term by the common ratio p. Question B, write down in terms of p the first four terms of the arithmetic sequence. So we'll just be adding 5p to each term. Our answer shall be 4, 4 plus 5p, 4 plus 10p, 4 plus 15p. Question C. If the sum of the third and the fourth terms of the geometric sequence is equal to the sum of the first and fourth terms of the arithmetic sequence, find the three possible values of p. Using our answers in A and B, we have our first and fourth terms of geometric sequence as 4p squared and 4p cubed. And the first and fourth terms of the arithmetic sequence are 4 and 4 plus 15p. So we get the sum and then we equate them. We shall have 4p squared plus 4p cubed equals 4 plus the sum of 4 plus 15p. So putting all similar terms together and writing this in general form, we shall have 4p cubed plus 4p squared minus 15p minus 8 equals 0. And then we use our GDC to find the values of p, particularly polynomial tools. So the exact answers for p are negative 1 minus square root of 65 all over 4, negative 1 half, negative 1 plus square root of 65 all over 4, or the approximation of these to decimals are given as this, and then we write our answers to three significant digits. So our p is approximately equal to negative 2.27 and a negative zero point 0.5, which is exact, and another approximation is 1.77. This is the last part of question number 1. For some values of p among those found in C, which is our answer previously, the sum to infinity of the terms of the geometric sequence exists. Question number 1, write down this value of p and explain why this is the value of p. So our p is equal to negative 1 half. The reason is for us to have the sum to infinity, the absolute value of p must less than 1. And this is the only value of p that qualifies for that answer. Okay, knowing our value of p, we can now find the sum to infinity. So the sum to infinity, using the formula use of 1 over 1 minus r, and then substituting all the values, 4 over 1 minus negative 1 half. So our sum to infinity is equal to 8 over 3. That's an exact answer. An approximation is 2.67. Question number 2 is worth 14 marks. In this question, give all the answers correct to the nearest whole number. It is highlighted to remind you what your final answers shall be expressed. The problem says Anne is considering investing $85,000 into a term deposit in one of two banks. The first bank offers an annual interest rate of 3% compounding monthly. The second bank offers a fixed payment amount of $250 per month. And there are questions that follow. You may pause this video to read each one of them, or you can just get your copy and read from it. Using the given information, we can now calculate the amount that would be in the account in the first bank at the end of the first year, and the amount that would be in the account in the second bank at the end of the first year. We can use our formula for compound interest, and this is highlighted in yellow, or we can use our TVM or finance solver, which is on the right side of this page. So for number one, in the first bank, there would be 85,000 times the interest, which is computed as 1 plus 0.03 over 12 raised to 12. So our approximation for this answer, which is to be written as to the nearest whole number, shall be $87,585. Or you can use your finance solver, where n equals 1, I equals 3, p is negative 85,000. P future value, that is what we're asking for. PMT, there's no monthly payment. So PPY, this is at the end only of 1 year, and its compounding monthly CPY is 12. So you will still be getting the same result when rounded off to the nearest whole number. It will be $87,585. For question number 2, we're looking for the amount that would be in the account in the second bank at the end of each year. This is a simple interest kind of problem. So we have 85,000 plus 250 times 12, which is the monthly payment. So it shall be equal to $88,000. Or you may also use your finance solver, where the I is 0, same PV, required is FE, but there is a monthly payment of 250, negative 250, because you are taking this from your money. PPY is 1, and CPY, PPY is 1 and CPY is 12. Oh, I mixed this up. And then you will still be getting the same result. In letter B, we are going to write down the expression for first problem, the amount in the account in the first bank at the end of the nth year. And second question, the amount in the account in the second bank at the end of the nth year. We are using our answers in A, or in part A, only that we have to express our answers in a more general sense because the year is not known. We are looking for the future value. So for first problem, it's equal to 85,000 multiplied by 1 plus 3 over 100 times 12 raised to 12n. Or we can simplify this as 85,000 times 1.0025 raised to 12n. For the second bank, the future value will be 85,000 plus 250 times 12 times n, or the simplified form of this, which is equal to 85,000 plus 3,000 n. Problem letter C. Calculate the year in which the amount in the first bank account becomes greater than the amount in the second bank. So we will be using our answers or the expressions in letter B. So the first bank is greater than that of the second bank. The expression we used there previously is 85,000 times 1.0025 raised to 12n, and that must be greater than 85,000 plus 3,000 n. This gives us n approximately 10.65, but we're looking for the year in which this happens, so that occurs on the 11th year. On the 11th year, you really have your amount greater in the first bank than in the second bank. Letter D, calculate the interest that Anne would earn if she invested in the first bank for 10 years. So the interest is equal to future value minus present value, or the amount you have actually paid minus what you must be paying. So that's 85,000 times 1.0025 times 12, raised to 12 times 10, okay, 10 for 10 years. Then minus the actual value is 85,000. That gives the interest of $29,695. Letter B, the interest that Anne would earn if she invested in the second bank for 10 years. So same formula. This would mean that Anne had paid 85,000 times 300 times 10 already, and then you subtract from it what must be actually paid, which is 85,000. So this the investment incur an interest of $30,000. Problem number 3 is worth 15 marks. Sophie is planning to buy a house. She needs to take out a mortgage of $120,000. She is considering two possible options. Option 1, repay the mortgage over 20 years at an annual interest rate of 5% compounded annually. Option 2 is to pay $1,000 every month at an annual interest rate of 6% compounded annually until the loan is fully repaid. Sophie decides to choose option 1. At the end of 10 years, the interest rate is changed to 7% compounded annually. There are questions A, B, C, D. For A, we have to calculate the monthly repayment using option 1, then calculate the total payments Sophie would pay using option 1. Letter B, calculate the number of months it will take to repay the mortgage using option 2. Then calculate the total amount Sophie would pay using option 2. And give a reason why Sophie might choose option 1 or option 2. And then using that answer in A1, calculate the amount remaining on her mortgage after the first 10 years. Hence, calculate her monthly repayment for the first 10 years. So the solution for this problem can be found on the next pages. So we are now ready to answer problem letter A. We have to calculate the monthly repayment using option 1. So we can use our finance solver here, but it is important that you identify the period used for this problem. So we say monthly, so we express our years in months. So our n equals 20 times 12, which is 240, and then interest is 5%. The present value is negative 120,000. Negative because this is something that we do not have in our hand yet. This is something we are working out to be paid. The PMT is what is known. Future value is 0. PPY is 12 because there are 12-month late payments in 1 year. And CPY is 1, annual compounding. The PMT is equal to 884.60376 and some more decimal places. And this rounds to $785. For question number 2, calculate the total amount Sophie would pay using option 1. So it will be the monthly payment times how many times she paid that, which is 240 months. That's equal to 188,304.9 and some more decimal places. But we are going to give our answers to 3 significant digits, so that is equal to $188,000. Question B, calculate the number of months it will take to repay the mortgage using option 2, then calculate the total amount Sophie would pay using option 2. So using our final solver for problem 1, our n is blank because we're looking for the number of months. So all the rest, you carry the same information as you were entering previously, and that gives n equal to 180.67 dot. So it will require 181 months. To calculate the total amount she has paid, so that's the monthly payment, which is 1,000 times 181 months. So I use the original value, number of months. So the total payment is 180,677 and more. And we need to express our answer to three significant digits. So the total amount paid approximately is $181. Question letter C. Give reason why Sophie must choose option 1. The monthly payment in option 1 is lower. She has to pay only $785 compared to option 2 where she paid $1,000. Why must she choose option 2? In option 2, the total payment is lower. We have computed that earlier. That is, she will be paying only $181 if $181,000 if she choose option 2 compared to option 1 where the total payment is $188,000. Use your answer to part A1 to calculate the amount remaining on her mortgage after the first 10 years. So in A1, we're looking for the PMT, so you can use the same where we will have already an entry for our PMT. But then here in this part, we're going to find the remaining amount to be paid, which is the PV. But we have to change our N to 120. Previously, you have 240 months, but since you have uh, been paying for 10 years, so you have 120 months remaining. So all the rest of the entries are the same. This will give you the present value, which is approximately equal to $74,400. Question letter B, hence calculate her monthly repayment for the final 10 years. Hence would mean using your previous answer, which is 74,400. So there are still 120 months to pay. Where do we get I equals 7? So you can see in the first problem, in the original problem, it says here, Sophie decides to choose an option 1, which is this. At the end of 10 years, the interest is changed to 7% compounded annually. So after paying for 10 years uh, with a 5% interest, there is now a change in the rate of interest. It becomes 7%. So our PV is 74,400. This is the meaning of the hence in part 2. You have to use the previous answer, which is 74,400. We're looking for the monthly installment, and then all the rest are the same. This will give us a PMT of approximately equal to $856.